Okay, so let's take a look at this one. We've got this table talking about drivers being intoxicated and pedestrian deaths caused by automobile accidents where drivers were intoxicated or not intoxicated. And then, of course, it also tells whether the pedestrian was intoxicated. But the truth is, for this particular question, all we care about are the situations where two different pedestrian deaths are randomly selected, and we find the probability that in both cases, the drivers were intoxicated. All right, so let's think about the case where in both that we draw, the drivers are intoxicated. Okay, so I'm gonna I've already copied it and pasted our table just so that we can kind of write on this and do what we need to do. So the first thing I need to do, and is I'm going to draw on this, is I need to get totals here. So I'm going to total 52 and 67, and I'm going to get the total for this row, which is 119. And then I'll get the total for the next row, 247 and 619, which is 866. And usually before we do these calculations, we want to get all the row totals and all of the column totals. So I'm going to do the column total. 52 and 247 is 299. And I apologize, I'm kind of slow when I'm writing on the screen and kind of like a first grader. And then the next column, 67 and 619 is 686. Now I can either add the totals that I got right here or the two column totals right here, and they should add up to the same thing, which is 985. I'm just going to kind of make some lines here. The overall total is 985. So there were 985 people in this study. All right, now we are interested in the cases where both pedestrian deaths involved a driver that was intoxicated. All right, so let's just think first of the probability of one person getting killed by a driver that was intoxicated. So, really, our probability that a driver is intoxicated is what we're looking at. There were 119 total drivers intoxicated out of the 985 people in the whole chart. All right, so there's our probability that one person was killed by an intoxicated driver, one pedestrian was killed by. Now, let's assume that we got what we were expecting. We got that intoxicated driver for this first situation. So now for our second person, there's now one less intoxicated driver because we chose one. We picked one already. So now there are 118 intoxicated drivers out of 984 people because we picked one already. And so if we multiply these two together, we get a probability of point, and I'm just going to round it to 4 decimal places, 0.0145. Okay, now for the sake of our problem, they wanted us to express this um, and actually, let me take this out a little further because otherwise, let me erase that. When we round here in a minute, because I think we needed to go to 1 decimal place when it came to the percentage. All right, so let's change that into a percent. So let's move the decimal 2 places, which makes it this. All right, now it told us though to round to 1 decimal place, so that's going to be 1.4% chance that both drivers were intoxicated when the pedestrian was hit. Now, if it had been 3 um, intoxicated drivers, we would have gone to multiplying by a fraction with 117 out of 983. Notice how we just assumed that we get what we were thinking about for that probability when we go on to the next fraction. Hopefully that's clear. But I think that will hopefully help you through these problems.